Inshallah, in this class, we are going to continue with Stokes theorem. In the previous class, we have already done one question in detail. I request the students to first watch that part. Inshallah, we are going to continue one more question based on Stokes theorem. In the previous class, we also write the detailed definition of that Stokes theorem. Just know I wrote the formula here. What is the Stokes theorem? Line integral f dot dr equals to surface integral curl f dot n ds. Let me go in detail in this. Okay, curl line integration f dot dr equals to surface integral curl f dot n ds. So one after one, let me see what the question is given. First, the question is given f equals to 2x minus y into I minus y z square into j minus y square z into k over the upper half of the sphere. You see here, this is the sphere, upper half of the sphere. Sphere equation is x square plus y square plus z square equals to 1. This is the equation of sphere. But you see here, we are going to bond it by the surface of the bonded by the projection on xy plane. So we have to project this on xy plane. Suppose this is xy plane. If we project this one, on the xy plane, we'll get a circle like this. If we project this on the xy plane, we'll get a surface like this. So this is the projection on xy plane. This is the projection. So when we project on the xy plane, you see here, the value of z will become 0. So I'm writing like this: on xy plane, what will be the value of z? Z will be 0. If we go like this, the z will be decreased, and on this plane the z value will be 0. So z equals to 0. If you differentiate, dz will also be 0. So in this given equation, we can write z equals to 0 and dz equals to 0. Dz equals to 0. First thing. Second thing, you see here, when we take what is the value of r value is xi plus yj plus zk. Also we write dr. So dr will become x will become dx I dx plus j dy plus k dz. So the value of r is xi plus yj plus zk. So dr will become I dx plus j dy plus z dz. And the next thing we see here, when we take what is the equation of sphere? Equation of sphere is x square plus y square plus z square equals to 1. When we take z equals to 0, this will change to circle x square plus y square equals to 1. This is the circle. This is the circle projected, that will become a circle on the xy plane. So for circle, we are going to solve by using, see here, parametric equation. In the previous classes, you have seen, suppose we are having the circle x square plus y square equals to r square. Its parametric equation will be x equals to r cos theta, y equals to r sin theta. I already have the z equals to 0. So let me take the parametric equation. We are going to solve using parametric equation. The parametric equation will be x equals to r cos theta. Here r is 1. So 1 into cos theta will be cos theta. And y equals to r sin theta. Now differentiate this one. This will become dx equals to dy dx of sin is dy dx of cos is minus sin theta d theta. In the same way, dy will be dy dx of sin is cos theta d theta. So in place of dx, we can write minus here. In the place of dx, we can write minus sin theta d theta. In the place of dy, we can write cos theta d theta. Okay. Just one after one, we are going the steps. First, we have written the formula on xy plane. Z will be equals to 0. Dz equals to 0. R value is this r is this value. When we take z equals to, this will become circle, and we have taken the parametric equation. So let me find first solve this equation. Okay, now what will be the theta here? For circle, theta, you see here, from here you are going one complete rotation, so therefore theta equals to 0 degrees to 2 pi. Theta will be 0 degrees to 2 pi, sorry, 0 to 2 pi. Just see. Next one is, let me find f dot dr. Let me find, for left hand side we are having integral f dot dr. Okay, so let first I am finding what is f dot dr implies here. f dot dr equals to, what is the value of f? The value of f is 2x minus y into I vector minus yz square into j vector minus y square z into k vector dot I dr. We have written dr here, I dx plus j dy plus k dz. Now watch carefully, this is the important step. You see, we are having z equals to 0. If you keep z equals to 0, this will become 0, this will become 0. We left with only I. So in dot product, we multiply the coefficients of I, coefficients of j, coefficients of k. Since z is 0, this 2 will become 0. So we left with only this. We have to multiply this with dx. Therefore, f dot dr, this will become 2x minus y into dx. But now we have converted this one into parametric form. 2 into x, we wrote already x cos theta minus y we wrote already sine theta, and dx, we got this dx as minus sine theta d theta. Let me write okay, minus sine theta d theta. Now you multiply, this will become minus into minus plus, and this will become minus. So f dot dr equals to minus into minus plus, sine into sine is sine square theta minus 2 sine theta cos theta. This will become 2 sine theta cos theta d theta. In the previous class, we have seen this formula 2 sine a cos a. This will be nothing but sine 2a. So this will become sine 2 theta sine square theta minus sine 2 theta. This is d theta. And now one more thing you see here. In integrations, we have to remove the square. Integration, we have to remove the square. Therefore, we can use one formula here to remove sine square. We use multiples and term multiples. This formula is 1 minus cos 2a by 2. So we can write loss here. This can be written as 1 minus cos 2 theta by 2 minus sine 2 theta. If you take LCM, this will be multiplied by 2. We can write like this: 1 by 2 into 1 minus cos 2 theta minus sine 2 theta. 1 minus. So let me integrate now. Therefore, line integration f dot dr equals to, now what is the value of theta? We know theta equals to 0 to 2 pi. 0 to 2 pi. F dot dr, we got this one. 1 by 2 is constant, we can write outside 1 by 2. And what is left here? 1 minus cos 2 theta minus sine 2 theta d theta. Okay, I'm writing this from the top of the board, no, just now. Now see here, let me integrate this one. Equals to 1 by 2 into integration of 1 is theta here. Integration of 1 is x, but we are integrating with respect to theta. Integration of cos is sine 2 theta, but we are having 2 with theta. Now we have to divide by 2 minus integration of sine is minus cos. So this is minus 1 is plus cos 2 theta. Again, we are having 2 with theta. Now we have to divide with 2. 0 to 2 pi. Now what is the formula we are having? Upper limit minus lower limit. If you put upper limit 2 pi here, this will become 2 pi minus, watch carefully, if you put 2 pi here, it will be sine 4 pi. Sine, you can write 2 into 2 pi 360. Since sine 360 is 0, this will become 0. This will become 0. Plus cos 360 will be 1. 1. So this will become 1 by 2. 1 by 2. This is the upper limit. As let me write the lower limit. Okay, you can take this value from calci also. If you take calci where sine 4 pi, you will have the answer 0. No, lower limit is 0. If you keep 0 here, it will be 0. Sine 0 is 0 plus cos 0 is 1. So this is 1 by 2. If you multiply with minus, this leave these zeros. Minus 1 by 2 plus 12 by 2 will get cancelled. 1 by 2 into 2 pi. 2 will get cancelled. Therefore, the left hand side we got line integration f dot dr equals to pi. Let me note this as equation 1. Now let me go for the right hand side. We have to verify means we have to do by both the methods. So for right hand side, let me see here what is the equation we are having. We have to solve this and we must get the same answer pi. So let me continue. I'm taking out this one. See here. Now what is right hand side? Double integral surface integration curl f dot n ds. Curl f dot n ds. See here. First I'll explain you the limits. Okay. Actually you see here we are having circle here, x square plus y square equals to 1. This is the circle. This is the circle here. Okay. Now see here. Let me take in x in terms of constant. If you keep y equals to 0, you will have x square equals to 0, x equals to plus or minus 1. That is, here x value is minus 1, here x value is 1. So we take x equals to minus 1 to x equals to 1, the limits for x. Now for limits of y, you bring this here, we'll get like this, y square equals to 1 minus x square. So y will be plus or minus under root of 1 minus x square. Y will be plus or minus. So we got the limits, x value from minus 1 to 1, y value from minus under root of 1 minus x square to plus. We have seen. Next one, let we go for curl f. Curl f. In the previous classes, we know what is curl f. Curl f is nothing but del cross f. So let me find this one. What we are having, how to find del cross f. Here we take I, j, k. Del means dou by dou x. This is we have seen the vector differentiation, dou by dou y, dou by dou z. How to find the curl f? Curl f is del cross f. Now here f coefficients, here we are having 2x minus y minus yz square minus y square z. So see here, let me solve this one. Now just now we have seen, we have already taken the value of z as 0. So this is 0, this is 0. So what is left here? If you take I, this will become 0 minus 0 0. If you take 0 also, z also 0. Okay, I will explain you. Let me do a thing. If we keep 0 and 0 here, because we already taken z equals to 0, suppose this becomes 0 and this becomes 0. Now let me solve this one. If you take I, we have to multiply this 2, this 2 will become 0. If you take sorry, this will become 0, and differentiation with respect to z of dou by dou z of 2x minus y, because we don't have z here, this is also become 0. So what is left? Lastly k is left. So this will become k into what's once more, when we take I, we multiply this, cross multiply this one, this will be 0 0. When take j, we multiply this 0, and if you multiply this 2, we have to differentiate with respect to z partial. If you don't have, that will become 0. Not lastly k, if you multiply this 2 will become 0 minus dou by dou y of 2x minus y. Now watch here carefully. If we differentiate this with respect to y, we don't have y here. D by dy of y will be 1. This will be minus 1 is plus 1. So k into 1. K into 1 will become k. So first step we have done, we already solved curl f. Now curl f dot n. Here you see here, curl f dot n will become, curl f dot n will become k dot n. Actually, we have to find n. N is the unit vector normal to the plane. But in this question, we doesn't require to find, because I'll just explain you. What is ds here? For xy plane, for xy plane, the value of ds will be ds equals to dx dy by n dot k. So this two will get cancelled. Therefore, we know doesn't require to find n. N is the unit normal to the plane. Now let me write the what right hand side, surface integration. What we are having, uh, curl f dot n ds equals to, now let me take the limits. First we have to write the constants. We have taken x in terms of constant minus 2 1 to 1. Then y we have taken in terms of x minus under root of 1 minus x square to plus under root of 1 minus x square. Now curl f dot n is nothing but n k dot n, or we can write n dot k into ds. The value of ds is dx dy divided by n dot k. So this n dot k will get cancelled. What is left here? X equals to minus 1 to 1. X equals to minus 1 to 1, and y equals to minus under root of 1 minus x square to plus under root of 1 minus x square. What is left here? This will get cancelled, left with only one. You write first dy, then dx. So you see here, if we substitute upper limit minus lower limit, integration of 1 will be y. Let me first write y. Integration of 1 will be y. So I'm writing one more step here. Integration x equals to minus 1, sorry, minus 1 to minus 1 to 1. Now integration of 1 will be y. This will be minus under root of 1 minus x square to plus under root of 1 minus x square. We can use here even function also. Just we change this one. What is left here? Dx. Now if you put upper limit here, it will be under root of 1 minus x square minus. If you put lower limit, again you will get minus. So minus on us will become plus. So this will be under root of 1 minus x square plus under root of 1 minus x square will be 2 into. Let me write 2 outside. 2 into integration of x equals to minus 1 to 1. What is left here? Under root of 1 minus x square dx. Now let me continue here. For this we can use a formula. For this we can use a formula. There is a formula. I'll just write on the upper. I'm writing the here. It will be clear. See here. I'm continuing here. So what is left here? We are left with the last step. I'm writing once more. Minus 1 to 1 under root of 1 minus x square dx. We can solve this by many methods, but I'm using directly formula here. Even you can take the value of this from calci also. See here. We are having one formula in the classes already. See here, this is the formula in the under root of a square minus x square is x by 2 into under root of a square minus x square plus a square by 2 sine inverse x by a. So let me use the direct formula from the previous classes. We have this formula. So 2 into, what is the formula here? X by 2, x by 2 into under root of a square minus x square is the same, 1 minus x square plus a square. Here a is 1, 1 square is 1 only, 1 by 2 sine inverse x by 1 will be x only, minus 1 to 1. If you take out this 2, this 2 will be outside. We can write 2 by 2. Now if you write upper limit 1 here, watch carefully, this will be 1 minus 1 0, so this will become 0. We already taken out 2 outside. Sine inverse 1 is left, minus. If you take lower limit, this again minus 1 square will be plus 1, 1 minus 1 0. You will have sine inverse of minus 1. So sine inverse 1 is nothing but 90 degrees. 90 degrees we can write pi by 2 minus sine inverse minus 1 will be minus pi by 2. So minus 1 will become plus pi by 2. Pi by 2 plus pi by 2, 2 pi by 2. 2 will get cancelled. So what is left here? We left with pi. So let we note this as equation 2. From the previous method also we got the same value pi. That is, we got the answer. Line integration f dot dr equals to surface integral curl f dot n ds. Hence what we can say, hence you write this, hence Stokes theorem is verified. So we have done one question. It's very long. Let we make one more part for one more question, inshallah. Let we continue in the next class. Let we make one more question based on the Stokes theorem. So I request the students to like, to share and subscribe this channel, inshallah. We are going to continue in the next class.